Hi everyone, just wanted to take a minute to talk a little bit about the lateral and total surface area of pyramids and cones. So to start things off, we want to make sure we are aware of what a pyramid is. So a pyramid is going to be a 3D figure. All the figures that we are talking about in the course of this chapter are going to have 3 dimensions. So there's some sort of length, width, and height going on. And now, instead of a prism which had 2 bases that were the same, we are going to have only 1 base in a pyramid. And that is actually how you will name it. So depending on what the shape is, again, that just like a pyramid, if the base, sorry, just like a prism, if the base was like a hexagon, it'd be hexagonal, and things like that. So the rest of the faces, again, we're going to call them the lateral faces. They're going to share one vertex. We actually have a name for that. So this top point up here, we actually call it the apex. Um, we don't really have to worry too much about it, but just know if you ever happen to see the word apex, that is the vertex where they all meet. And again, it is named for the base. So, right, you have a pentagon, hexagon, square, or potentially a rectangle, triangle. And all of these faces right here, right, all the lateral sides are going to be triangles. And because they're triangles, and you know to find the area of a triangle, it's 1/2 base times height, we're going to need this thing called the slant height. So instead of necessarily before where we were, finding the perpendicular line, we actually need kind of like the diagonal height, where if I took one of those triangles, I need the height of the triangles. And we're going to call it the slant height. So to find the surface area of a pyramid, we can use the formula 1/2 perimeter of the base times the slant height. So again, the slant height, as you can see here, it's not the perpendicular height of the pyramid, not from the apex down to the, let's say, center of the base. We're talking about from the apex to the center of a side. So that's what we're talking about when we say slant height. You just got to be careful with that because we need the area of the triangles, and you need that slant height for that. Again, alternatively, let's say you forgot about this. You could just find the area of each of the triangles and then add them together using the information you have. Now, once again, then, once you find the lateral, to find the total, you just have to add in the base. All right, except now it's even easier because we only have 1 base as opposed to before where we had 2. But again, the big thing here is you need to remember to use the slant height, not the pyramid total height. Okay, so for example, if we found the lateral area, which we'll do first, we have to ask ourselves, okay, it is 1/2 the perimeter times the slant height, and we usually use kind of like a cursive L for that. So it was very nice. They gave us the slant height right here. They gave us a slant height of 13. And we have 1, 2, 3, 4, 5. So we have 5 sides. And we have a side length of 5. So we have a perimeter of 25 times 13. All right. So we will need to multiply these. Now, I'm going to be honest, I don't off the top of my head know what 25 times 13 is. It is 325. And I'm actually just going to leave this over 2 because I don't, why put the decimal in? But there's no need. Feet squared. So that's the lateral surface area. Now to find the total, we need to add that to the area of the base. All right, so we need the base. Now we have a pentagon, a regular pentagon. So we are going to have to find the apothem so that we can find the area of the different shape. All right, the pentagon, which means if I just look at the pentagon here, I am going to need to find the central angle. So we have 360 divided by 5, which is 720, not 720, 72. So then when we set this up, right, we have to cut this in half. So this ends up being 36. we have a side of, again, we cut it in half, so 2.5. And I need the apothem here. So we have opposite and adjacent. So we have tangent of 36 degrees is equal to 2.5 over the apothem. So when we solve that, we get the apothem is equal to 2.5 over tangent of 36. All right. Now, depending on where you start plugging things in and rounding, your answers might end up a little bit different. So I'm going to just plug it. I'll plug it in here. 2.5 divided by tangent of 36 ends up being approximately 3.4. We'll use 3.4. All right, so now we need the area. So the base, the area of the base is 1/2 the apothem, 3.4, times the perimeter, which is 25. So when you plug that in, you're going to get 3.4 divided by 2, 1.7, times 25, so plus 42.5. Now, 42.5, what's that as a fraction? Well, ask yourself, if it's over 2, you would just kind of double, so 84, and then the half, so 85. Okay, so that would be equal to 325 over 2 plus 85 over 2, which is equal to, add the 5, 410 over 2, which is about, I ran out of room, 205 feet squared, roughly. And again, that's kind of with a little bit of rounding with the trig going on here. So again, depending on where you round, you might end up a little bit off of that. But as you can see here, with the way I rounded and how I was able to kind of get the fraction, it's actually a little bit easier to manipulate as opposed to dealing with all the decimals that you're adding together. All right. Now, next shape we need to talk about is the cone. So a cone, again, it's kind of similar in shape to a pyramid, except now instead of having a base that's a polygon, the base is going to be a circle, which means we don't definitively have like triangles. We kind of have this almost, if you unfolded it, like a ice cream cone looking shape. Like if you were to do like a cutout of an ice cream cone. So ultimately, again, we have the slant height, which is the side. We have the height, which is an altitude, and the base. And so again, the important things are going to again be those slant height and the radius, or the sides, so to speak. The side, well, it's not a side in a cone, but you get the point. The radius is always important. So to find the lateral area, it is going to be pi times the radius times the length. And if you kind of almost can think about it, it's basically we're saying, okay, we're just taking a bunch of these circles and we're kind of adding them up. There are a number of proofs for cones that we're not going to directly look into in terms of where these formulas come from. But they usually kind of involve like a sector when you unfurl it, you can kind of break it down. It does kind of work out to this, or I should say it does work out to this, but we're not going to go look at the proof for this time. And then, so the total surface area is once again going to be the area down here, which we already found, the lateral area, plus the area of the circle on top. All right, so again, be careful, you need the slant height. So we are not given the slant height. So first things first, this is a right triangle. So to find that slant height, you can use the Pythagorean theorem. So 7 squared plus 21 squared equals slant height squared. Okay, so we have 49. Let's see, what is 21 squared? Well, what's 49 times 9? 21, 441. Oh, that's nice. The slant height squared. So we have, when we add the 9, so 50, so 490 squared. So the slant height is going to be the square root of 490, which, as you can clearly see, is going to be 7 root 10, because that's 49 times 10. Okay, so we have our slant height and leave the radical. Why put all these unnecessary decimals that it makes your answer less exact. So to find the lateral surface area, we need the radius times the slant height times pi. So radius, which is 7, times the slant height times pi. Okay, so that is 49 root 10 pi. And I understand that doesn't look nice, but it's more exact of an answer. Please leave it. Okay, so there's your lateral and your total surface area. We'll have to just add that to the area of the base, which this is actually relatively straightforward because it's just pi r squared. So it would be 49 pi. Let's see, is there anything I can simplify? Well, they both have the 49 and the pi. So I guess you would have... well, if you take the 49 pi out, we have 49 pi root 10 plus 1, which I guess we'll just leave it as, but centimeters squared. I would have also just been okay if you left it like this. But ultimately, for the purposes of this, that would be how you find the surface area of a cone. All right, so just to recap, you have to be careful with the slant height. Make sure you do not use the actual kind of altitude. And again, if you have a square root on any of these, if you have a square root, if you have a pi, leave it. The only time I really want to see you start using decimals is if you have to plug in something involving trig, because you can put in like tangent of 36, but that one I would like you to use the decimal answer. All right, let me know if you have any questions, and have a great day.